I have a few slides about how Python fits into the data science world. And I have a lot of slides on Python in general, but if we don't get through them all today, that's totally fine. In the tutorial, we can go finish up the last few slides. Actually, the last maybe 10 slides aren't relevant for the first week anyway. We can come back to them later in the term. Python, okay, it's a general purpose programming language. Now, this is probably quite different to most of the programming languages I imagine your background is with. If you're coming through this school, you would have been taught R, which is not a general purpose. It's a domain-specific language to try to make statistics easier. And it does that. It does a good job of that. But the great thing about Python is you can do so much more than statistics once you become competent and confident with it. For example, a whole big chunks of the internet are powered by Python, like Instagram, Spotify, Netflix, all running Python in the background. I recommend you check out this free book, Automate the Boring Stuff with Python. Like this is the, what's that quote from Bill Gates? It's like when he needs something done, he finds a lazy person to do the job. They'll find the most efficient way to do it. That's kind of along these lines, right? You can use Python to automate so much of the computer drudgery that each of us does on a daily basis, like related to Excel spreadsheets and so on. I even put down that Python is on Mars. Where's that? There's some specific badge you can get if your code was part of some of the common Python data science libraries that were installed on that rover, the last Curiosity rover that NASA sent to Mars. So even on GitHub now, you put a little badge saying that the code that you contributed is totally on another planet, and that's really cool. And the Stack Overflow developer survey is a huge survey for all developers, not just actuaries or data science people, but people who do programming for a living. And the 2023 dev survey is out at the moment, actually, but I should have updated these slides for 2022. But if you look at the most popular languages, the first two are kind of forced on people because if you're doing anything to do with the internet, you kind of have to use these three technologies. But when you get to the ones where you choose to use it, Python is the most popular. And then when you ask in the survey, what's the language that you most want to work in? Python wins on that category. Later on, there's different frameworks and libraries that they ask do you use, and many of the Python data science ones are high up on those kind of lists too. GitHub has a similar kind of statistical every year state of the GitHub universe, and the top languages has been pretty consistent. That Python's been high since 2014, but it's getting even higher as time goes on. And one final quote before I get into the Python language. This is from the guy who invented Keras, which will be learning this term. The entire machine learning data science industry has been dominated by deep learning and gradient boosted trees. They tend to use scikit-learn, that the libraries they tend to use are XGBoost or LightGBM. And most deep learning practitioners use Keras in combination with TensorFlow. The common point is that they're all Python libraries. Python is by far the most widely used language for machine learning and data science. So I added this in the reading list. There's this book on Python data analysis if you want extra resource to look at. It covers a lot of things that I had to teach myself the hard way. But when I remember I moved not from R to Python, but I moved from MATLAB to Python, which is another domain-specific language. And at first, it can be a little bit annoying that things that are sort of easy in one language slightly more inconvenient than the other. So it's this kind of obscure function, p just q in R, right? That's just available to anyone that opens R. They can just type that immediately. Now, Python is not for statisticians. So if you want that functionality, you have to bring in the statistics part of the scientific Python library and say, okay, using the statistics library, I want to get the chi-square distribution and I want to evaluate the CDF at that point. So there's a bit more typing here, but in the long run, these packages that Python has, there's so many of them, and anything you can do, anything you want to do, Python has an answer for it. I've heard it said that Python is the second best programming language for every problem, basically. So I forgot to fill in this slide, but the title says it all. Basically, during the course, I see people when they try to pick up a new programming language really stress out about making mistakes or what can go wrong. Well, it's not like if you make a mistake in your Python code that a nuclear bomb is going to go off, right? The consequences actually, during this term at least, very low. So I encourage you to really just play, experiment, break some code, see why does it break, and don't stress out. Python is well, learning any programming language is just a lot of trial and error. So if you're seeing lots of errors, that's natural. If you need to Google a lot of things, that's natural. But at the end of the day, Python is a language that you can learn. I mean, they teach it to young children in schools these days. So it's definitely a problem that you can pick up. You're some of the smartest people in this university. I'm sure you can do it. I recommend for most of the class, at least for the first part of the term, that you run your Python inside of this website, Google Colaboratory. So if you have a Google account, then you can create, go to this website and create notebooks of code. So when you type code in here, let's say 1 + 1, then you press the plus button and it'll run the code for you, the Python code. The very first time you do it, it takes a while because actually Google has a cloud infrastructure, and before you press play, it hasn't actually given you a computer to play on. It's actually run R on. So the very first time it goes and finds you a computer with Python installed, and then so there's a little bit of a lag before that very first one. And then later on, if you want to add more cells, add more code, and then you press this button to add more code, and you can either keep pressing the play button or the keyboard shortcut is Shift-Enter to run that cell. Later in the term, well, one nice part about this is that all of the libraries related to deep learning and data science are already installed on this service for you. So you don't have to stress about installing all the dependencies. So that this will make your life easier at the beginning of the term. And another good reason why Colab is useful for us is later on, you might want to come up here and go change runtime type. And here where it says hardware accelerator, normally you're running on a kind of a slow computer, just on the CPU part of the computer in the cloud. But you can come here and say, give me access to a GPU, a graphics processing unit. And if I don't recommend this most of the time, but if later on maybe we're doing image processing, this probably help you out. And then when you hit save, what it does is it kills the computer that you were previously using, and then finds you one which has a GPU attached to it. And then, so if you had any variables here, they'd be totally dead. You'd have to go back and run all your code again. But in theory, then your deep learning stuff should run a bit faster, quite a bit faster, depending on the problem you have. Now these things you can save the notebooks to your Google Drive, and they don't run forever. Actually, if you're not sitting here using them, then maybe after, I don't know, half an hour or an hour or something, they just turn off. And if you want more time with it, they actually, I think they give you more time if you don't ask for a GPU. So I recommend don't choosing that option until you really need it. Yeah. Okay. And let's start off with the very basics of Python. So data, variable and data types. So the basic numeric data types are integers and floats. So whole numbers and fractional numbers, basically. We go 1 + 2, we get 3. The integer addition. If we want to save the value of the integer 1 into the variable x, then we use this beautiful, the most natural way to do it is x = 1. And any other programming language that uses a different thing other than the equal sign is objectively wrong. And the equal sign is the most clean way to do this. So x = 1, x gets stored in the variable 1. And then later, if we do x + 2.0, now it's adding together a integer value thing to the 0.0. It turns it into a floating point value thing. So the output is also a floating point value, 3.0. If you don't know the type of any object in Python, there's a built-in function called type. Put type, parentheses, the thing you're confused about, and I'll tell you what type it is. So float. Type of 1 and the variable x are both integers. Now, basic checking equality is done using double equal sign. So double equals means is the left-hand side equal to the right-hand side? So does 1 + 1, is that the exact same as 2? And so that's a big yes. But there's no, the equivalent of yes in Python is true. And if you print that out, this is what it looks like. The type of it is bool, named after some long dead computer scientist, Boo. I actually don't know his first name. If you want to check, does the left-hand side not equal the right-hand side? You do exclamation point equals 1 does not equal 1. Well, that's a contradiction. You get false. Oh, yeah. So for this kind of case, I normally actually would put parentheses around these things just to make it obvious that we're asking this question first, and the output of that question, true or false, gets stored in the variable. But according to the latest style guides, that's actually not the correct way to do it. Okay, shorthand assignments. So it's often that you want to update a value. So here we have a value of 1, and we want to replace it to be to add 2 to that value. So x = x + 2. The faster way to do that is to start with your x and then go plus = 2. And you will get the same output. Oh, I probably should have mentioned too. In this kind of cell in a notebook, if you have some variable like 1, 2, 3, it by default will print out whatever was on the last line here. So if you actually wanted to see something that was on each of the previous lines, you have to manually print them out like that. Okay, back to shorthand assignment. If we say with a variable, we want to subtract 2 from its current value, we have minus equals. We want to double the size of it, star equals. And if we want to halve the value, / equals. Now, strings and string processing are some of the best parts of Python. You can create a string using either the double quotation marks or the single quotation marks. There's no particularly good reason to pick one over the other, but most of the time, so just pick one and stick with it. There are special cases where, see, if your string actually had a quote in it, like Patrick's coffee, then you're better off using double quotes on the outside to avoid an error. The alternative would be if you had single quotes here, right? You can see that possessive here cancels, it's sort of interpreted as at the end of the string, and that turns into an error. Otherwise, when you want to combine strings together, if you just add them as if you would add numbers, it does string concatenation. So it just makes a new string with the contents of the first one, and then right beside the contents of the second one. If you want to put strings together, though, it's more natural to use what's called an F string, short for formatted string. So here you set a template of what your string wants, you want your string to look like. So I want it to look like hello, then I want it to have a name and then a surname. Because I start with an F here and I have these braces followed by variable names. It'll go grab the value of those variables and then put them in that location of the formatted string. So my greeting at the end of the day is hello, value of name, Patrick, value of surname, Lorb. Later on, if I want to ask, is the string Patrick, is that a substring of the greeting? You can just ask Patrick in greeting, true. And or, also just the normal English words you can use in the program. So if I want to ask, is my name and surname, are they both in title case, which means they start with a capital letter and are followed by lowercase letters? Are they both title case? You say name.isTitle and surname.isTitle. And if both of those are true, we get a true. Another example for all, I would say, is this person a doctor? So either their full name starts with doctor or it ends in PhD. And if either of those is true, then we get a true. For our users, the full stop, the period, has special meaning in Python, so you can't use it inside of a variable name. So if you try to do something like this, you'll just get bizarre errors. Any questions so far? Okay. So if you need to get help on any of the built-in parts of Python, or any of the functions in Python, say I didn't know what that isTitle thing was doing, can we say help and then brackets and then the thing that I'm confused about, and it should give you some information about it. So here it tells you that it's true if it's title uppercase letters followed by lowercase letters. This is just more details of how those formatted strings work, but I'll skip over that today. Converting between different types in Python. So I start off with the number 3, which is an integer value, a whole number. I can ask what the type of it is and find out it's an int. If I want it to be floating point, though, I can use float like a function here and put the name of it, parentheses, and then my variable, and then it becomes floating point. So when we print it out, we can tell it's floating point because instead of just 3, we get 3.0. And the type of it is now float. In the same way, if we needed it to be a string, we can put that num variable through the str function and get the string which contains the number 3.0. Okay, so what's the output of this? This is a quiz question for you. Let me see, actually, do I? No, okay. So I'll have to just use the chat to get your answers for this one. Okay, first guess is true, false. Let's see, any other guesses? Should be able to get at least a few more people responding to that. Yeah, I imagine you're right. Yes, true and false as formatted in that specific way. The string is printed like that. Okay, now the addendum to that. What would you put before line 3 to make the answer output true and true? Got one answer. There's actually a couple of different ways to solve this problem. So even if you agree with the answer that's written in the chat, maybe you can try a different one. Yeah, I think you've got it. So you can do, if you want them both to be this true, you mean the type has to be the same. So either you convert X to be a float, or you convert Y to be an int, which is what you wrote, or even the answer I didn't even consider, just redefine Y to be 1 exactly. And then you get the right answer. Well, very good, very good. Let's keep blasting through. Collections. So one way to group items together in Python is in a list. So we can, here is my list of desires, which is things that I'm usually happy for: coffee, cake, and sleep. And to put them in a Python list, I use the square bracket syntax to say this is a list, and the items in the list are separated by commas. This is a list of strings, and there's a built-in function len for any collection. I can ask how long is it, how many items are in that list, and there are 3. Now, there's another thing that will look strange to our users, but wouldn't look strange to people from nearly any other language, is that if I want to get the very first element of the list, we start at number 0. And this is, well, once you get used to this, trust me, this is going to be the natural way to do things. And there are computer algorithms that really make life easy if you start at 0. And most programming languages ever created have this behavior. So once you get used to this and you pick up JavaScript or C or even Java, and well, any modern programming language, you'll find that this is exactly how they behave. So when I read this code, I see what's the first desire in the list: coffee. Now, Python also has this interesting thing where you can go backwards too. So this is index 0, 1, and 2. But in the same way, you can count backwards and say, this is index -1. This is index -2. This is index -3 from the end. So another way to read this, when I see this code, I just say, my brain reads it as, what's the last element of the list? So that's sleep. Now I can use this syntax not just to get values, but also to set them. So instead of a full-on sleep, if I just want to have a little nap, I can say desires at index of 2, replace that with nap. And next time I print desires, sleep, which was index 2, as well as index -1, becomes nap. With lists, once you get used to this indexing, you can do this operation called slicing. And what that does is gives you a range of values inside the list. So I've printed out 0, 1, 2 alongside the desires, so we can sort of more easily see index 0 is coffee, index 1 is cake, index 2 is nap. If I use this index 0:2 inside here, instead of giving just one number, I give 0:2. That means a range of numbers. Give me all of the elements of desires, starting at 0 and going up to 2, but not including 2. So we get, starting at 0, we get index 0, we get index 1, not 2. So that's why we get coffee and cake as the output of that. Now, a slightly stranger version of this is, say, 0 up to 1. That means give me index 0, but not index 1. We're not including the second one. So we get the list, which contains just one value, which is coffee. Now, that's actually different to here. If we just ask for, give me 0, I just get a string back. I just get just pull out the first element. This is slightly different. It's saying it'll give me a list which contains just one thing in it, which contains coffee. So there's a subtle difference there. Each of these ranges, though, because they start at 0, is sort of the most common way to slice things. You're normally grabbing things from the front. So there's a shorthand, which is if you just don't put the 0, it just assumes that you've put a 0 before the colon there. So desires :2. Now that I know Python, I just read that immediately as give me the first 2 elements of the desires list. And that's another equivalent. Indexes can't be floating point values though. So remember I said because there's a 0.0, this is interpreted as a floating point value. And you'll get an error if you try that. Now this is, I mean, it's pretty rare for you to actually try to do this manually and get this error. But say, for example, you wanted to grab the middle value, the item that's at the middle of this list. You do that. The first half of the list. So colon here means get everything up to the first half. And then you go the length of the list divided by 2 as the upper bound of the index. Well, then this is 3 divided by 2. You actually get 1.5, a floating point value, and you get this error. So that's what I wrote here. Len of desires divided by 2 gives you 1.5. But if you do, this is a very rare notation. I doubt you'll ever need it. If you double // it does integer division, which means it does the division, but then it gives you the like it rounds down the number. So 1.5 gets rounded down to 1. So if you do that now, that's equivalent to 0:1, which is again just a list containing just the first element. Now lists have the property that they can be changed. Here, for example, I mean, these are my 3 favorite things, but in life, but a close fourth is buying new gadgets. So if I want to add that to my desires list, I go .append. And when I look at desires next time, gadget becomes the very last element. If I want to get rid of it, there's an equivalent way to get rid of it, pop. If I want to sort it, .sort with the brackets, will sort at the list and it will compare the elements in the list using whatever is the sort of natural way to compare that kind of data. So for strings, the natural way is sort of alphabetically. So we start off cake, coffee, sleep. Now, one thing that our users might want to try is to make the list bigger. Say if I wanted to add another desire, croissant, another really high up on my list of desires. If I wanted to add that at the end, so currently the list has maximum index of 2. Say I wanted to add it at index 3, and I try that, we actually get an error. So you're not allowed to use indexes that don't exist like that, like you do in R. You just have to append it. Okay, so what have we got here? So the none type. So we have desires is now this list of four values. Now, if I sort it, desires.sort, and I try to save the output of that into a new variable called sorted list, if I print it, because it's the last thing in this cell, we should be able to print it, we actually don't see anything, right? So there's actually nothing there. Now, that's not some bug. That's just because if we look at the type of that thing, it's actually none. So this is a common, maybe not a common, but it could be a bug that you might come across, because this here, desires.sort, doesn't actually return a value like a normal function. So when you try to assign it here, you just get the value of none, which is a keyword in Python. If you want to check, is this none, you can go sorted list, is none, get true, we have none here. Well, that's sort of a curiosity. Now, what's the other way to do this? So if the problem here is that desires.sort if we look at it when I did it here, we had desires, coffee, cake, sleep. If we desires.sort, this version takes the variable desires and modifies it directly. So it doesn't actually give you back anything because it's already modified the variable that we started with. So desires itself has now become cake, coffee, sleep. If you wanted something different, if you instead wanted a new list which contained a sorted version of desires, but desires were to be kept, not unchanged. The way you would do that is there's a different function called sorted. There's a sorted, pass in the variable, and this will give me back the sorted version of the given list. So now desires hasn't changed. It's still coffee, cake, sleep, gadget. The sorted list is now cake, coffee, gadget, sleep. And another data type which is used all over the place, but maybe I actually don't think R has a version of this, or maybe I just don't know R well enough. It's called a tuple, and that's like a list, but it's can't be changed. So the fancy computer science way of talking about that is immutable. So it cannot be mutated. I feel like I've misspelled that word now. Now I'm looking at it. Mutable. Oh, no, okay. Immutable. Now, it has many of the same properties of a list, but you specify them using parentheses rather than the square braces from before. So here are the different kinds of weather we could have: sunny, cloudy, rainy. If we print out the type of it, we see that the sort of funny made up sounding word is tuple. That's the name of this data type. We can still ask for the length of it. So there's 3 elements in there. So we get 3, and we can still do things like index. Index from the beginning, index from the end. So -1 will give us rainy, the very last one. But if we try to modify the tuple, by adding a new element to the end of it, you get, can't do that. Same if you try to grab that index 2, 0, 1, 2. If I were to replace rainy, try to replace rainy with snowy, also can't do that. You get an error. That's what it means to be immutable. Another fundamental data type that you might see is a dictionary. The great example for this is imagine that you're trying to represent a phone book in your program. So phone books, dictionaries have a mappings from keys to values. Just like a phone book, if you ever had the white pages growing up, is a list of names. That's what you're using to look up to the phone book, and then the value associated with it is the phone number, so you know how you call them. The Python dictionary is just like that. You specify it using these braces. Then each key value pair is separated by a comma, but each key and value is separated by a colon. So now this is my phone book, where I can say, given my phone book, what's the phone number for Patrick? Using the indexing notation of, just like we did before with lists, and it would give me back the number that I stored in there. That same updating syntax works. I say, given I have a phone book and I have a value for cafe, and I want to replace it with a new value, that works as well. When I print the phone book, the cafe number has been updated. Come back. And there are ways to pull out all the keys and all the values separately from the list. Now, this example was the keys were all string values, and the values were 2, but they don't have to be strings. Like here we're hard coding. Factorial of 0 is 1, factorial of 1 is 1, factorial of 5 is 120. So these are numeric values, integer values for both the key and the value. But you can mix them up, so that you could have a key, which is a string, and the value, which is a float. So it's just a general structure of keys and values. Can be very useful. Okay, yeah, I think we have time. Let's try this out. I actually can't remember the answer to this one. So let me know in the chat what you think is the printed out version, what gets printed out using this code. I only got one answer so far. We can do better than that. Actually, I realize we've got some very privacy conscious people in the lecture today with one or two letter names on your Zoom account. Okay. Okay. So we've got 1, 2, 3, 4 answers now. Let's see if any of them is right. 4 and 5. Actually, I was going to say 4 and koala, but I can't even remember my own slide. So yes, 4 and 5 is the answer. How does that work? We get dog, cat, bird. Then we get teddy bear. Then pop deletes the last element from the list, and we do it twice. So bird gets removed too. But then we add back on koala and kangaroo. Now we ask what's the length of the list now? There's dog, cat, koala, kangaroo, 4. And then this part is a bit tricky. Get the second last element of the list, so kangaroo, koala, and how long is that? And that's actually 1, 2, 3, 4, 5 letters in that. So actually, it was a little bit tricky because I didn't actually show you that the len worked on strings. Now think about it. Okay, in the last few minutes, let's see if we can blast through a bit of control flow. So if and else act like the English words. So we can say if we have a variable age is 50, and we say if space and then some condition which is true or false, ended with a colon. If age is greater than or equal to 30, print, man, you're really old. And that applies to me. And now you can do an alternative, say if age is greater than 30, and then you put else, and this is lined up with the if, then the condition, if this were false, then the code down here would run instead. Actually, I probably forgot to mention, Python is a bit strange than other languages. The one most unique feature about it is that if you put space, the spacing here is part of the programming language. Good, I have already slide on it. So for example, if we had that code, but we forgot to put the spaces to line up the print up here, we'd actually get an error in the code. So just watch out for that. And maybe it looks like you're working, maybe when you've got your code, it looks like this, but you're still getting this indentation error. That could be you're mixing up tabs, which is, on the keyboard, the tab key is actually inserting something different than the space bar. So that's one thing to check out. Given the time, I might skip through these examples to get to for loops. So now we've got our loop, our desires list again. Now I can operate on each element of the list individually. So I say for, and then I make up a variable name here, can be anything. I typically, if the list is named something with a plural, the element in the list, I usually give it the same name without the plural. So for desire in desires, colon, then in here I can operate on this code will run once for each element of the list. So the first time I get Patrick really wants a coffee. This is true. Patrick really wants a cake. True. Don't necessarily need to sleep just now. If you want to loop through just a list of numbers, the easiest way is to ask Python as a built-in range. So if say range of 3, that'll give me the numbers 0, 1, and 2. So starting at 0 and going up to, but not including the number you put in. There's ways to get ranges that don't start at 0. So starting at 3, but not including 6, 3, 4, 5. And yeah, the range object itself is a bit tricky. If you want to loop through a list and get the value, but also the index of the value that you're currently at, there's a built-in thing called enumerate. So if I enumerate my desires, then I can say for I, comma desire, where I is the index and desire is the value. I can say Patrick wants A, and then this is the element of the list, and this is priority number, index +1. Patrick wants coffee, index of coffee is 0, add 1 to it is priority number 1. So this can be quite useful. Skip while loops because they're almost never needed. And I'll skip the quiz, which you can play with yourself, just to show you what functions look like in the last 2 minutes of the lecture. So when we make a function, we use the def keyword, short for define. So I want to define a function called add1, and it takes in an argument, which we're just naming x, and we'll give you back a value which is x + 1. A different way to do another kind of function is here as one, greet a student, takes in a name. Now it doesn't actually return anything. It just goes and runs some code with that value. Say, hi, name, welcome to the class. So add1, put in the number 10, it'll actually return something. Greet a student, if I actually try to save that to a variable, well, I'll get none again because it's not returning that. It's just directly printing to the screen the welcome message. And the great thing about functions is you have the same bit of code run on different data, and you can avoid reusing code. If you want to have arguments which are default, so you don't have to type them in every time, so you can use this equals syntax. So imagine that we already have a variable, a function called simulate a standard normal random variable that generates normal 0, 1. And we want to make it a more generic function, which is just generates any normal random variable with any mean and any standard deviation. Then you can use the syntax so that even if the user doesn't put in an argument, it will default to a mean of 0, and it will default to a standard deviation of 1. So here, simulate normal 1000. That's as if you were to type it out fully with a mean of 1000 and a standard deviation of 1. We can skip that. And I think maybe this will be the last slide for the day. So functions can return 2 different things. So here, let's have a function called limits. We pass in some numbers, and it will give me the minimum and the maximum number. When we return with a comma like this, we actually get 2 values out of as a return value. In fact, it's really a tuple which contains the element 1 and the element 5. But this is kind of nice too. If you have your function limits, and I pass in the list of 1 to 5, I can actually say unpack that tuple, as it were. Say store the small value in a variable called minnum, and the large value in a variable called maxnum, and use the variables directly. This can be really nice. An alternative is if I actually have this function, but I don't care what the minimum number is, the Python thing to do is just to put an underscore, and it sort of throws away that value. Okay, and sorry for going over time. As I said, those last bits of Python we can go through in the tutorial or the start of next lecture. And I hope you enjoy the class. I'm looking forward to getting to meet you all, preferably in person sometime. And I'll see you next week for the next online lecture.